Alright nerds, so we're going to talk about an atom and what it is that makes it up. Basically we're talking about a model, okay? This is a way we describe nature that is as close to reality as we can get right now, okay? So this is our understanding of the atom. So study of the atom is a study in physics, and it was previously thought to be this solid, indivisible little ball, the way we talk about particles in the earlier years. But through a series of pretty rad and cool experiments, we've shown that this is not even close to being the case. And in fact, what we tell you in this lesson is it's even much more intricate and smaller parts than that. Okay, so basically we're also able to use the periodic table to identify different properties of it. Now, by the end of this lesson, you should be able to both explain the model of it and use the periodic table to work out a couple of things. Alright, so you should already know that every atom is an element, so each different type of atom is an element. Molecules have multiple atoms, okay? And compounds have multiple types of atoms. So, alright, so here we've got a carbon atom, oxygen atom. They're elements, they're separate. There's 92 of those, okay, that exist in nature. Here we have, down here we have a compound, because we've got oxygen atoms and carbon atoms, that's carbon dioxide. And here we have, this is a diamond, but that is a molecule, but it is an element at the same time. It's not a compound. Alright, so the current model of the atom, well, it has a very densely packed nucleus in the center, which is massively heavy, and it has so we're going to the nucleus first, it looks like. It has protons and neutrons. Now the protons have the positive charge of the atom, and they have a mass of 1 atomic mass unit, and it's a relative unit that comes from essentially the weight of a proton. And it has a neutron, which has a neutral charge and 1 atomic mass unit for mass. Cool. Around it in shells it has electrons. These have a negative charge, equal to that of a proton, but they are about 1/2000th of an atomic mass unit, so they're much, 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 much smaller. And the electrons move super rapidly around the outside of the atom. So they spin around the nucleus in shells, and each shell holds a certain number of electrons, but they do this, constantly. Alright, so here's how we use the periodic table. First off, at the top here we have the atomic number. Now the atomic number basically equals the number of electrons and the number of protons. So a neutral atom, which is basically a standard atom, has the same number of protons and electrons. Alright? Here we have the symbol /name, and this would be for krypton. And here we have the atomic mass. So we can see that that's much higher than the atomic number, and we can use that to work out the number of neutrons. For example, the number of neutrons equals the atomic mass minus the number of protons, which is the atomic number. So neutrons, if you ask to work out how many protons it has, it's this number. Electrons, it's this number. But when it's neutrons, it's, in this case it would be, so rounded up to 83.8, so it would be 84. So the number of neutrons would be 84 minus 36, which gives us, 78.48. That's our number of neutrons. So that's how we work that out. And that's pretty straightforward. There's not a lot of drama there. Don't forget, bring a question. Fill out the form beneath this in the wiki space. And yeah, we'll see you in class.